Okay, so we're back with another episode, and we're still talking about natural ventilation. If you didn't see the previous episode, we talked about doing modeling natural ventilation with operable windows. This time, we're going to talk about modeling natural ventilation with a more purposeful design of natural ventilation. So in this instance, we are going to talk about using the whole building for natural ventilation. And so let's take a quick look at this. What does this look like? And we'll just take a snapshot of our building, and you can see that. So in the previous episode, what we did was we had a simple window, and the ventilation was coming in the bottom of the window. It was circulating through the room, and then it was going out the top of the window. So in this episode, what we're going to talk about is doing ventilation with the windows again, but in this instance, the air is entering through the windows, and we're going to assume that there's some sort of chimney at the top of the building, and the air is going to escape through that chimney. And that allows you to take advantage of the thermal buoyancy, the stack effect, to get more natural ventilation into your building. And there's some terminology that we need to discuss, similar to last time. As part of this natural ventilation, there's going to be what's called a neutral pressure level. So at this neutral pressure level, you have, it's an arbitrary place in the building where the pressure is, the pressure is causing the air to enter the building below this level and exit the building above this level. And this neutral pressure level can vary dependent on the temperature differences between the inside and the outside, and also the wind speed and wind direction. But for convention, this neutral pressure level can be approximated as basically half of the distance between the top and the bottom, the inlet and the outlet. And so this is the value we'll be working with right here. So let's take a look at what that looks like. Going back to our model, we took our model from a previous episode and we've saved it as a new version. We can go to thermal zones. Let's go to measures first. And we will go ahead and delete that operable windows that we did last time. And we'll go to thermal zones tab. And we go to the library and go down to zone ventilation, wind and stack open area. And this is the same object that was being used in the previous episode, but it was being applied to only the windows. In this instance, it's being applied to the whole thermal zone. And so we can drag this in and we will apply it to our thermal zone. You can apply this to any zone you want. For this example, we're just going to apply it to the zones with windows. And we will run the model and compare this model to the previous one with simple operable windows. So this is assuming operable windows, but it's also assuming that we're going to have that ventilation coming into the window and somehow it's going to escape out the top of the building. So let's take a look at this object. And you'll notice that almost all of these inputs are the same inputs as we did last time. So the first input that we're going to have is called opening area, and we're looking at zone 1. So let's take a look at zone 1 right here. So the opening area is going to be, essentially our windows once again. So, and we can have SketchUp calculate those window areas for us. If you just hold down the Shift key and select all of these windows, we can see that the total area is about 270 square feet. And this is actually in meters, so we can go to Preferences, Units, change it back to English, 270 square feet. The next step is the open area fraction schedule. So this is the fraction schedule that we created in the previous episode. And what is it called? Natural vent window fraction schedule. So we're going to use the same window opening schedule as we did previously. The opening effectiveness is based on those equations that we talked about last time. Again, you would have to look into the input-output reference manual or the engineering reference manual for EnergyPlus, and you will find those equations there. But for us, we will just leave it to auto-calculate, just as we did last time with the measure. The measure uses auto-calculate as well. And the effective angle, so that angle is based on orientation from true north. If we go ahead and look overhead on our model, you can see that the green axis, that is true north for our model. And so we will be using that as the direction of 0, and it goes around clockwise in degrees. So this zone 1 is actually located at an effective angle of 180 degrees from true north. The height difference is, again, it's going to be that distance between the middle of the window and the neutral pressure level. So it's going to be this distance right here. That's what the height is. So we can calculate that using SketchUp. We're just going to extend this out, and we'll just draw a midpoint of the windows and draw this up there. So SketchUp is telling us that this line is 16 feet. So it's going to be approximately half of that, so we're going to say 8 feet. So we'll do 8 feet here. Discharge coefficient for opening, again, that's based on the equations that we talked about last time, and you can find those in the reference manuals. The minimum indoor temperature, we can look at our previous example to take a look at what those parameters were, and we will use the same numbers just so we are comparing apples to apples on this simulation. So the minimum indoor temperature was 21.67 Celsius. We'll have to change back to units metric. 21.67. Maximum was 40. The delta T was 3. The minimum was 18.33. And the maximum was 25.556. And the maximum wind speed was 5.4. And we'll go ahead and save the model. And we're going to apply this object to all the other zones with operable windows as well. So we can select these other 3 zones, select the object, and apply to selected. And the only thing that we have to change now for these other zones is the opening area and the effective angle. So let's take a look at zone 2. The effective area is 176 square feet. For zone 2. And let's change this back to English. 76 square feet. And the effective angle for zone 2 is 90 degrees from true north. Let's go to zone 3. Zone 3 is facing true north, and the window area is 180 square feet. Facing true north. And then finally zone 4. The window area is 120 square feet. And it is facing 270 degrees from true north. And that is the parameters that we can input for our model. And we're going to go ahead and run our model and compare it to the previous model that we created in the previous episode. So the simulation has completed successfully. We could take a look at the output reports and simply compare energy use intensity. But for this example, we want to compare the ventilation flow rate of this natural ventilation. So we went ahead and selected some output variables on the Output Variables tab. And we're going to use dview to view those. So these output variables record some variables during the simulation. I cover this on some of my other videos, so we won't talk about that now. But if you go to the top right and click the Show Simulation button, it will take you to the Run folder for the simulation. And we're looking for the EPLUSOut.SQL file, and we're going to open that using dview. And we're going to select outdoor air dry bulb temperature, zone mean air temperature for zone 1, and zone ventilation standard density volume flow rate for zone 1. And likewise, we're going to do that for the previous simulation we did with just the operable windows. So this is just simply the operable windows. And this is the simulation using the operable windows plus exhaust at the top of the building. You can see there's quite a bit of difference here. We're getting a lot more ventilation flow through the building using that stack effect versus simply just opening the windows. And you can see that this ventilation increases during the more temperate portions of the year, and it decreases towards the more extreme conditions because we do have that we do have those upper and lower limits on our natural ventilation. So, and that is how you do natural ventilation in a zone, as opposed to doing natural ventilation just through windows. Thank you. Please like and subscribe.